Okay, it's Mr. Robs here, and we are going to look at another problem with volumes and surface areas of combined figures. And here we have a company who's designed a portable Bluetooth speaker. The speaker is in the shape of a cylinder and a hemisphere on each end. So a hemisphere and a hemisphere on both sides. The dimensions of the speaker in centimeters are illustrated, and there's a radius r and a length L. And we know that r and L are both positive. It says write down an expression for the volume of the speakers in terms of r, L, and pi. Okay, so if I'm going to do that, and so as we look through this problem, one of the things that we should do is we should read the problem all the way through first to get a sense of what is coming our way. And so the next thing we're going to have to show is like the surface area is 300 and show that L is this scenario here. And then hence it says show find the volume is this equation. And then we're going to have to sketch it below on the grid, sketch the graph of V, indicating maximum and minimums, and then find the length of the cylinder for which it is a maximum. So we've got to find L. And finally, use parts of D and E to identify the shape of the speaker for best sound quality. All right, so let's get into this problem. I'm going to delete this part of the scenario, so let us see what we can come up with here. So we want to add the volume. I know is going to be half a cylinder plus another cylinder is a full cylinder. So I want the volume of the cylinder. Oh, I said sphere. I mean half a sphere and half a sphere. And if we use our formula booklet, we know that the volume of a sphere is 4/3 pi r cubed plus the volume of the cylinder, and that is also from my formula booklet, pi r squared h. All right, so now we know we have these, but h in our case is not actually h, but it is L. So my height is L. So I can call it L. And so here is A part done. Going to B part, it says it needs a surface area of 300. Show that L is equal to that. Okay, so if I want to find the surface area of this speaker, the area I know is going to be the entire sphere, which is 2 parts. And if I use my formula booklet for that one, that is 4 pi r squared is the area, surface area of a sphere, plus the curved area of the cylinder is 2 pi r h, which h is actually L in this case. So this is also from our formula booklet. And I can show you in here where we can see that. So here is the volume of our cylinder. Here is the curved surface of the cylinder. And then our sphere, here's the volume of our sphere, and here's the surface area of our sphere. So I know that the surface area is equal to 300 in total, and I need to show that this is true. So now I just need to rearrange this equation to try and get it solved for L. So I'm going to subtract. I know that 2 pi r L is equal to 300 minus 4 pi r squared. And then I'm going to divide by 2 pi r. Divide by 2 pi r, both sides by 2 pi r. This cancels, and so L now, when I look here, I can divide 2 here with the 150, but I also have to divide both of them by 2, both terms. And so now I can say that L is 150 minus 2 pi r squared over pi r. I cannot cancel the r's because there's no r here. I cannot cancel the pi's because there's no pi with the 150. And I believe that is what I was looking for here. So now it says, hence, show that the volume is this equation. Well, I can recognize that L is equal to this. So I'm going to substitute my L into here. And let's see what we get when we do that. So when I substitute the volume is 4/3 pi r cubed plus pi r squared times L, which is 150, minus 2 pi r squared over pi r. And now we have to simplify this. If we consider what we can cancel here, I know I can cancel out a pi here and here. I can cancel this r with one of those r's. And now I can distribute the r into here. And so I'm left with 4/3 pi r cubed plus 150r minus 2 pi r cubed. And so now the 4/3 pi r cubed and minus 2 pi r cubed, they're like terms. So I can combine them. I could recognize that 2 is the same as saying that it is 6/3. And I say that so there's a common denominator. And so when I can go 150r, 4/3 minus 6/3 is minus 2/3 pi r cubed. And this is my formula for volume. If I look up top here, that's what I was asked to show is true. And the fact that you have to show that it's true, you have to go through, don't skip any algebra steps that you can do in your hand. Be very clear that you can show that it is actually the formulas that are given to you. All right, so there's the first part. Let's continue on with D and E. So I've kept this here so I can see these L and this V. And one of the things I want to make note is, like, if you did not know how to do this, it was still possible to do C part. If you don't know how to do C part, it is still possible to do D part. And when you're doing reading time, those are some of the things that you should pick up on. And so the next part says the quality of sound from the speaker will improve as V increases. On the grid below, well, here's the grid, sketch the graph of V, clearly indicate maximums, minimums, points, and intercepts. So I'm going to take my V and I'm going to plug it into my calculator. And I've already taken the liberty to throw it in. But then I want to put it on this graph. And if I'm clever, I will change my window to fit what's going on here. So I want my minimum to be -1, my maximum to be 11, and I'm going to go by ones. And then that's what the scale here says, is going by ones. And my y minimum, well, I'm going to go -50 all the way up to 600. And let's make the y scale also by 50 because it's going by 50s. And so when I then sketch my graph, the window I have here is an exact copy of this. And so then I can easily sketch this on. Now, this is always tricky to do with the pen, so it's going to be something similar to this scenario here. Okay? And so I know this is 11, so that's 10, that's 9, that's 8. It should be between 8 and 9, so it really, let me try that again. So it's going to go between 8 and 9. It's here at 0, 0. The maximum is at about 1, 2, 3, 4, 5, and up to here about 500. So 5 and 500-ish. So somewhere around here. And I'm going to sketch it to be like that. Okay, it wants me to clearly indicate maximum, minimums, and intercepts. So if I calculate my maximum, number 4, my left bound will make it 2, my right bound I'll make it 8, and I'm going to guess it around 5. And so I can see that this point here is 4.89, comma 489. 489. This point here, I think it's 0. That's 0 here, so this is 0, 0. And then finally finding this intercept here, we'll have to go find the 0 and go 2. My left bound will make 5, my right bound will make 10, and we'll guess it around 9. And so this is 8.46. This is 8.46. And so then I have clearly indicated the maximum, minimum. So here's my maximum. there's no minimum, and the intercepts. And I have the general shape correct. Okay, so there's D part. E part says find the length of the cylinder for which the V, the volume, is a maximum. Well, here is my maximum volume. So I want to find the length of the cylinder when the volume is maximum. My radius for the maximum is 4.89. And so that means this value here is R. I'm going to use R equal to 4.89. And to keep all my decimal places in there, I'm going to recalculate the maximum. And the reason why I'm doing it is that's going to put the answer into my X value. And so then I'll have it stored in X. So now my X is the maximum R, or the R that produces the maximum volume. And so when I plug that R in, I get L is equal to 150 minus 2 pi 4.89 squared over pi times 4.89. So I'm showing the calculation I'm doing. This is going to be my method point. And then if I just use my calculator, if I make myself a fraction, and I go 150 minus 2 pi x squared, because the x is from my graph. It remembers it. So you have to be careful not to change your x if you're going to use it. And then I'm going to go pi times x. And so when I do that, I get negative 8.33 times 10 to the minus 6. So this is basically 0. That's what that number means, is approximately 0. So now it says find the answer, using your answers from D part and E part. So I have a radius of 4.89, and I have a length of 0 to identify the shape of the speaker with the best quality sound. Well, if my length is 0, if this is 0, that means this isn't there at all. And this will connect to here. And so the shape I will get, and I'm going to have a sphere as my speaker shape. Okay, so this is a multi-step process using your calculator wisely with the Windows setting, using X to calculate exact values the best you can, and going through steps using various information, even if you couldn't get it, to move forward in the problem.